Systems of inequalities. Basically what we're doing here, ladies and gentlemen, is we're going to graph inequalities, 2, 3, 4 inequalities on one graph paper. All this means is that we're going to take one piece of graph paper and graph multiple equations on it, or multiple inequalities, excuse me. That's it. That's all this means. So in essence, we are saving the environment. One inequality at a time.
Or we just not do it.
We could. That's progressive. It is. So what I want to do is try a couple of them, and you probably still have some graph paper from notes stuff from the other day, right? I'll give you guys more graph paper tonight because I've got, I think, 6 problems for the evening, so it's not too bad. But what I want to do is walk you through the basic way of graphing these, and then the cover and solve method again. Remember we talked about that the other day when we had that, when it was in standard form for solving via intercepts? That method, guys, is going to become so awesome starting really basically tomorrow, because you'll be able to graph things so much faster. And what we're going to be able to do is create what are called feasible regions. And that's where this whole thing gets into next week. Next week is when we start talking about what's called linear programming. Linear programming means we're going to take some sort of a feasible region that we graph out that has some specific value that we'll be able to get intersection points and know which way things are being directionally shaded. So for something like this, the shaded region would be in here, and I have 1, 2, 3, 4, 5 different values of ordered pairs that I'll be able to test into some cost analysis style problem. Something that will have to maximize profits. How many bran muffins you have to sell and apple muffins to sell to make the most money, that kind of thing. All right. This is one way that we do these types of problems. But what we do is, to start, is remember how to shade and create shaded region style problems. So these are both slope-intercept form. Do we agree? So if I do the first one, where do you start that graph? And then what do you walk? Down 3 over 1. Good. Start at -1. 1 little, 2 little, 3 little spots. 1 little, 2 little, 3 little spots. 1 little, 2 little, 3 little spots. 1. Or the opposite of down and right is up and left. 1 little, 2 little, 3 little spots. 1. 2 little spots. 1. And then you ask the question, is it a solid or a dotted line? Solid. Why is it solid? It's got the equal to thing. We are almost done with the problem. We have to find the shaded region part now. So, did this graph go through the origin? No, because its y-intercept is at -1, so we know it doesn't go through the origin. So what we do is we use what's called a test point. We're going to test it at 0, 0. Just like we talked about the other day when we had number line testing, you tested it at 1 value. Was it true or false for single direction number line shading? Here it's 2 direction, because it's XY grid, it's 2-dimensional. We have to pick a double set value. Is 0 bigger than -1? Yes. So it is true on this side, which means it's false on this side. Bless you. So what side are you shading? Shade the truth. Always try to cover up. That's it. And then you go to the next graph. What?
Didn't we just do this like the other night?
We did. But now you're just putting 2 on the same paper. But it gets into a little bit more, because we'll actually do one with an absolute value thrown in here. And then we'll start doing them with specific parameters, like x is greater than or equal to 0, y is less than or equal to 2. And we have to put those in as well. And I'll start to show you guys how that's going to start to look as we go. Y is less than x plus 2. Where do you start? 2. And our slope is? kind of boring to sing this song with one little over one little over one little over one little over one. Do I connect those dots? La 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 la.
No.
No. Did it go through the origin?
No.
No. Where are we going to test it at? Hey, if it goes through the origin, where would you test it? Anywhere it doesn't go through. Like 10 in 2 or 77 in 5. Doesn't matter. So is 0 smaller than 2?
Yes.
Yes. So it is true again on this side. So our shaded region is over here. Now, what this allows us to see then is that the favorable region then is a solution set to both inequalities is in that rightish area. No, don't erase it. Don't erase it. Do you notice how my two lines are going different directions? That's all I do. That's all this means, guys. It means that any point you pick that's in that double shaded region is an answer for both solutions. That's it. Or it's a solution to both systems. Okay. Thank you. Equal math. It's math good. It's math strong. Grr. Me fail English. That's impossible. Okay? Let's throw an inequality, or excuse me, an absolute value in here. Now, yesterday, I showed you guys the generic form of an equation in terms of absolute value. When you have an absolute value graph, or the standard form of an absolute value is y equals a absolute value x minus h plus k. Where in the case here, this value of h and k is the vertex-ish of where the two sides of the absolute value meet. Because remember, absolute value is linear, it's symmetric linear. So positive slope one side, opposite of that the other side. It just folds into itself. It's up, I want to say up like a cup, but no. Or it's down depending upon the a value. The a value, if it's positive, means it's going up. A value is negative, means it's moving down. Which means all we're doing is playing around with slopes. So this value of h and k is what we call our vertex, if you will. And this a value is your, technically it's the slope. What's that? I know, just reminding you. You'd be surprised at how many times people don't remember things that I say from yesterday. But apparently you remember Forrest Gump. Okay. What's out in front that you don't see? Oh, 1. Yeah. It goes along the same idea as if you had a linear equation, y equals x minus 3. What's the slope of that? 1. And if I do the absolute value out in front of it like this, it still means that the a value hiding out there is still going to be 1. That's all. It's a great question.
So whenever there isn't an a,
Yes, ma'am. And if there's no k value, what is it? It'd be 0. Because if it was a 1 value, you'd have plus 1. If there's no k value, it means it's 0, because if you add nothing to something, it's still something with nothing added to it. Is it okay if I rewrite that top inequality as 3x plus 2? And then we start.
It's like you do that with any kind of like equation, you can like switch them, right?
Yes.
Like it's like switch sides. Does it matter which equation you start with?
No. It doesn't matter. The reason I started with that absolute value one is just because it's newer. I figured to start with it. So our absolute value graph tells us we have a center at 3 and 0 and a slope of 1. You okay with that? So I start at 3, 0. Slope of 1. Because the k is, it's plus 0. So the k would be 0. H is your, remember, H is your horizontal shift, the x shift, and k is your vertical shift, up and down, the y value. This generic form is x minus h. Think about point slope form. If it was y minus 3, that meant that the y coordinate was 3. If it's x plus 3, the h value would have been negative 3.
Oh, so whatever.
When you see these things with the minus in there, just think of the opposite sign. So if it's x minus 3, it means it's a positive 3. Okay. And then since one slope was positive 1 going up and right, I can do the symmetric slope, which means I'm going up and left 1. Solid or dotted line to connect those? Yes, ma'am. Correct, because of the bar. Okay. Did that absolute value go through the origin? No. So we'll test it. So if I'm going to do this at 0, 0 minus 3 absolute value. What's 0 minus 3? What's the absolute value of negative 3? 3. So is 0 bigger than 3?
Yeah.
Fine, I'll give you nothing, you give me $3.
All right.
Sweet.
$3.
You should have asked for more.
It's true.
So it's false here, which means it's true inside. Okay? So as we start to get into these absolute value graphs, you could have inside the V or outside the V shaded. As we get into quadratics, we could have inside shaded, depending upon parameters and whatnot, and we could have outside shaded. We could actually even come across and have the shaded between 2-point lines and just get little regions too if we wanted to get real fancy. There's a lot of stuff we can do with these things. Yes, Miss Lori?
Can you just go back to the question that you did?
And then lastly, I go to 3x plus 2. Where do you start that graph? And then you walk your slope of?
3.
Three little spots. 1. Solid or dotted? Did it go through the origin? What's 3 times 0? What's 0 plus 2? Is 0 smaller than 2? So I shade to the right. So my overlap winds up inside here. That's it. Oh, really, in all honesty, guys, what I want you to take from shading these style problems is that you're just reusing the same piece of graph paper. That's all it is. You're just graphing more than one piece on there. That's it. Nothing crazy, nothing fancy. It's just sharing paper or saving the entire thing.
Yay, I'm teaching at a young age.
Yeah, right?
It's true.
Yeah, I know, we should have this paper now.
So let me show you something that you can do without graph paper. Let me show you what happens here. This is going to be more important, bless you. This is going to be a lot more important as we get into tomorrow and then next week. Tomorrow what we're going to do is practice a ton of this style problem. And then I don't think I'm going to give you much, maybe 4 or 5 of them over the weekend. Okay? But the idea here is that we start to understand what regions it's asking you to graph. So if I start my graph and I start thinking here, x is greater than 0. When x is greater than 0, that's everything to the right on the y-axis, correct? Y is greater than 0 is everything up from the x-axis, isn't it? Which means right off the bat, what quadrant am I looking for the solution sets to occur in? 1. Quadrant 1. You guys remember your quadrants?
Yeah.
Only that on that, like, don't mix those positives one with negative 1, 2, 3, 4.
Ladies and gentlemen, one of the nightmarish things about the 4 quadrants that never disappears is that later on into second semester when we do trig, we live in a world that is all consumed by the unit circle.
No.
The unit circle is all built off of,
No.
the unit circle is built off of your special right triangles. Your special right triangles of the 30, 60, 90, and the 45, 45, 90.
Is this what we have to do geometry?
Kill me now. I don't want to include.
As you get into this portion here, you will start to realize that you have specific ordered pairs here. This ordered pair is symmetrical to this side. This ordered pair is symmetrical to this side, and back and forth. What happens is these values, as they come across, if this is a positive x and a positive y, if it stays on the same y value, just switches x, it becomes negative x, positive y. If it goes vertical from that same spot, it's negative x, negative y. As it flops back over here, it's still positive x, but negative y. What occurs then is that you're going to be able to decipher cosine, sine. Cosine and sine are positive, first quadrant. Cosine's negative, sine's positive, second. They're both negative. Cosine's positive, sine's negative in the fourth quadrant. Which means, as you get into it, tangent's positive here, because tangent is sine divided by cosine. Tangent's negative here, because sine divided by cosine would be negative. Tangent would be positive here, because negative divided by negative is always positive, and then it's negative. And it all comes back to the 4 quadrants.
I'm going to have to pretend like I didn't hear this and just be surprised when it actually happens.
No, and you're going to be, and I know that, and I know Seb beat you guys over the head with 30 60s and 45 90s, and I know that I did that to my guys too. There is a huge advantage to really understanding what a 30-degree or 60-degree angle looks like and how you know the relationship to the side lengths. Because if you know those 3 angles, you know everything on this without even thinking. I'm not lying to you guys. You can ask pre-calc kids that are in there this year, and the AP calcs that had me that are in there right now. When we do this trig stuff, yes, it starts off like a train wreck, but 2 weeks, a week or so into it, they're like, oh, that's all it is because it's a quadrant and it's mirroring itself because of symmetry. It's so stinking simple. It really is. I love trig. It's one of the cool things I get to teach. I really enjoy doing this stuff. Anyway, back to here. So look at Duck. We now know that by these first 2 bits of information, x is greater than or equal to 0, y is greater than or equal to 0, tells me that I'm only going to wind up looking for the first quadrant style problem. Okay? So then I go to my 3rd equation, or inequality. This is written in that standard form, ax by equals c. You could solve for y and get your slope-intercept form, but it's a pain in the butt. Because cover and solve. If I cover up my y value, if I cover up my y value and I solve for x, that tells me what my x-intercept is, because I'm saying my y value is 0. Whenever you have an x-intercept, you're on the x-axis, your y value is 0, so what's your x-intercept? 6. And I would put a dot at 6, 0. That's my intercept. And the other one is at 8. I put a dot, 0, 8. How many points do you need to have to determine a line? 2. Connect the dots.
Is that a quick graph?
It's a quick graph.
I couldn't see yesterday because when you're standing there and covering, I can't see any of the.
All I hear is I move my seat.
Neither can I.
And now, what's that? Now, I have to decide what side to shade. Did that line go through the origin? No. What's 0 plus 0?
0.
Is 0 smaller than 24? I shade inward and I'm done. So my feasible shaded region is now bound by a triangle.
Why you said we didn't need a graph?
We didn't.
Most of it.
That's fairly.
What I meant by is you don't need a physical graph to plot this. I should rephrase that.
Okay.
Because what you're going to eventually be doing, maybe not so much today, but especially tomorrow, we're going to start doing stuff like this where you're not going to use a graph. I want you to create your own. I want you to just start to visualize, okay, I'm going to place 6 about here, so if later there's an 8 one, I just move it further over, and then I know that lines would intersect. You get good at this. And we're going to be doing this stuff for about a week. Okay? And it's not that this part is going to be the difficult part. It's going to be eventually, you're going to have to come up with your own equations and inequalities for parameters to solve systems. And that's where things can get a little dicey. Men? That's really all I had.
Field trip?
Field trip. Let's go bother Mr.
No, we're not going to bother Judkins. I think he's got planning 12th hour
Let's
anyway.
go bother stuff.
No, we're not bothering Sev.
You won't mind.
What problems were these? This was on 154, I think.
No, he's planning.
Oh, wait, I put it in the calendar.
I don't fall over.
Hey, knuckleheads, you guys remember where I put the calendar?
Yeah.
All right. So today is Thursday. It's highlighted. It's September 1st. If I click on it, look, there's homework problems.
Oh, great.
I don't know.
Oh, Jory.
Convenient.
I haven't looked at the calendar since you showed it.
Wait, keep it up there.
I will. I'm going to put it on a sheet.
Okay.
I have graph paper. If you want some extra graph paper, I have some. You might have some left over because I think there's only, what, 5? There's 5 or 6 problems, so if you've got enough spaces, if not, I've got more graph paper. Please help yourself. If you guys wanted some graph paper, come grab some. Des would be more than happy to hand it to you because she's awesome like that. And go from there, okay? There are a couple of them that have that parameter setting where you're just y is greater than 0, x is greater than 0. If you want to try those first, guys, if you want to try the couple that have like quadrant setups, if you want to try those without a graph, give it a shot. Okay, it's not a big deal. The only other weird thing with this section is that the book, which is weird, one of these tabs. If you look at 46, see on number 46, it gives you the x is greater than equal to 0, y is greater than equal to 0 last. Whenever you see problems like 46, 47, 48, where you have singular values where it's just going to be a horizontal or a vertical line, do those first. Plot those on your graph first before you do the other stuff. It makes it a little bit easier. The old textbook always put those values first. I don't know, I guess for the past 9 years of using that old textbook, I'm so used to it being that way, so that's why I say do that. But you guys don't know any different, so it doesn't matter.
So basically, we're just doing like the same like what you just did on
Yes,
the
ma'am.
board, just with the graph paper.
Yeah. That's it. All right, give them a shot.